So what I want you to do, I know sometimes you guys skip around. Please, please, please start on number 1. I'm guessing you might have problems on part C and part F, possibly the other parts too. But I will go over part C and F in about 5 to 10 minutes. And then what I think I'm going to do is similar to last time is I will kind of send a chat out saying, hey, now I'm going to go over number 2 or number 3 or whatever ones you guys might need some help on. I would like you guys to try them before I do that. But that way I can kind of answer those questions. And if you have a question before that, or maybe you just need to know how to get started or you got stuck somewhere along the way, please, please, please call me into your breakout rooms. I'm happy to do it that way as well. But I'll kind of go into your rooms and see what ones you guys need help on. But like I said, in about 5 or 10 minutes, I'm going to go over parts 1C and 1F. So try A and B, try C. Please, please, please try it. See if you're able to figure it out, but you may be getting stuck on part C and or F. So with that, I will assign your break. Okay. So number 1, I think it's a little confusing. So when you're hammering nails into a piece of pine wood, the nail travels, the distance the nail travels is always less than the previous hit. So after the first hit, the nails traveled 16 millimeters. At the end of the second hit, the nails traveled 14 more millimeters for a total of 30. For example, 16, 14. So if this is arithmetic, so arithmetic, remember, is adding or subtracting. Your equation here for the sequence, since we would be subtracting by 2, would be negative 2n plus 18. Part B, they would just want you to find h of 5. I'm not going to do that. What part C is when will you finish hammering if the nail is 70 millimeters long? So you could just keep writing the sequence out and adding up all of the terms. The problem is if you get a really big, if it was going to be a large number, that's going to be a lot of work. So we want to know how many hits it will take for 70 millimeters. So we're looking for the series. So we're looking for 16 plus 14 plus all the way to the last hit would be negative 2n plus 18. So this would be our first hit. And this is going to be the last hit. We just don't know what n is. So for an arithmetic series, remember it's the sum of the first n terms is n divided by 2 times the first plus the last. So you're just plugging it in here. 70 equals, because that's what it adds up to. That's how long the nail is when it's all the way in. N divided by 2 times 16 minus 2n plus 18. So we get 70 equals n divided by 2. This is going to be 34 minus 2n. So 70 equals, if I distribute here, half of 34 is 17. So 17n minus n squared. So since this is a quadratic, you want to get it equal to 0. I'm going to move it to the left side so that I have my n squared as positive. It would be n squared minus 17n plus 70 equals 0. Then you'd solve that. Quadratic formula, factor, whatever. You're going to get 2 answers. I'm not going to solve that for you. With your 2 answers, only one of them will make sense. If one's negative, that wouldn't make sense. If they're both positive, you just care about the smaller number because that's when it's going to first hit 70. And then down here, if it's geometric, so this one's a little bit trickier. if it's geometric, we know we are multiplying by some number. So our sequence is 16, 14. And so we want to know, what do we multiply by? So 16, I'm just going to call it, so R. So 16 times R is 14. So 16R equals 14, or R equals 14 divided by 16, which is 0.875. And so if you try that, so I just did 14 divided by 16, but if I do 16 times 0.875, that's going to give me 14. So that's my multiplier, or the common ratio in this problem. So h of n equals the first term, 16, times our multiplier, 0.875, to the power of n minus 1. Part E, you're just finding h of 9. And now it's saying, okay, what if the nail is 100 millimeters long? When will you finish hammering it? So same idea. We could write out this sequence by multiplying by 0.875. And you'll see, so 14 times 0.875, we get 12.25 times 0.875. Our decimals get longer and they become uglier numbers. So this one is a lot more work to kind of write it out. You could have easily done it here because it's just going down by 2 every time. So here for our sum of n for a geometric series, we know is, what is it? The first term, or t of 1, which is the first term, times r to the power of n minus t of 1 divided by r minus 1. So that's just the formula for a geometric series. So remember, this one is 16 plus 14 plus the 12.25 plus ... We want to know, and the last term would just be this. We don't need the last term here, but I'm just saying this is what it would look like. So we just plug it in. It's 100 millimeters. Our first term is 16 times our multiplier is 0.875 to the power of n minus 16 over 0.875 minus 1. So I'm just going to simplify that denominator first. So this right side has a denominator of negative 0.125. So if I multiply both sides by negative 0.125, so 100 times negative 0.125, I get negative 12.5. So this is negative 12.5 is equal to 16 times 0.875 to the power of n minus 16. We're solving for an exponent, so you're going to want to isolate this 0.875 to the end. So add 16 to both sides. Then you're going to divide by, so this one will be gone and you'll have a different number over here. Then you're going to divide by 16. So you're going to keep going until you have something is equal to 0.875 to the power of n by itself. And you'll have a number over here when you just do those 2 little steps. And then you have to turn it into log form. So that's going to be what you have to do to finish solving this one is use logs. It's not E because it's just not so it's not natural log, I'm sorry, because it's not an E. So you want to turn it into log form, and there's a couple of different ways you can do that, but it'll be an exponential form, so you just want to turn it into the equivalent log. You're going to get a decimal on this problem. It doesn't work out as nicely. And so say it said 27.5. Say it said 27.1. You would have to round up to 28. You always are going to round up no matter what comes after the decimal here, because you need that last hit, even if it's just part of a hit. So that's going to be how you finish up number 1. Part B, we know the sum, and we wrote it like this: t of 1 times r to the power of n minus t of 1 divided by r minus 1, where t of 1 is really just the first term. So on this problem, our first term is going to be when we plug in 5. So this is going to be 48 times 1/2 to the power of 5 minus 4. That's going to be the first term here. R is our multiplier, so that's just 1/2. And n is then how many terms we have. Same thing, I would count them. We plug in 5, we plug in 6, we plug in 7, we plug in 8, we plug in 9, we plug in 10. So n would be 6 here. So now you have enough information to plug it in so that you can solve. And I did, I believe, already type the answers out. So you should get 161 for A, and B should be 47.25. And now I'm going to let everyone know that I'll go over number 3. So for number 3, there's a couple of different ways to do this. If you want the fourth term, so this is to the power of 7, you can get out Pascal's triangle. You can kind of think about what the whole thing would look like. So off to the side, I'm just going to do, what if this said a plus b to the 7th? So if this said a plus b to the 7th, and we'll just ignore that for now. Going to your triangle, your coefficients are 1 plus 7 of something plus 21 plus 35 plus 35 plus 21 plus 7 plus 1. So, and remember the way the exponents work. This would be a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, and a to the 0. And this would start with b to the 0, b to the 1st, b squared, b cubed, b to the 4th, b to the 5th, b to the 6th, and b to the 7th. Remember, your exponents always add up to whatever the power was. So I understand we didn't have to do all that. Hopefully, but that doesn't really take that long. We want to know what is the fourth term. So 1, 2, 3, 4. This is the term we are looking at here. But this wasn't our problem. In our problem, our A value is 3m. That's the first term. and our b value is negative 1/3 n. So if we just kind of plug those in there, this is the only term we care about. We don't need to plug it in everywhere. We don't even need to simplify this. Yes, we know that this just becomes a to the 7th. We only care about this term. So here, if I simplify, this is, or plug them in, I'm sorry, 35 times 3m to the power of 4 times negative 1/3 n to the power of 3. That says negative 1/3 n. I should just fix it. And so we're just multiplying all this together. Well, 3m to the 4th, that becomes 81m to the 4th, because we multiply the 3 together 4 times. Negative 1/3 to the 3rd is negative 1/27th, and then n cubed. So if I multiply all this together, 35 times 81 times negative 1/27th, I get negative 105 m to the 4th n cubed. Okay, so on number 5 here, I went over it a little bit. That's why I'm covering this up like this. So Davis had an account that pays 7% interest compounded continuously. So that's this formula that we came up with yesterday. How long does it take for his money to double? So they're not giving us a P, that initial value that we can start with. We want to know when his money doubles. So P was 1,000, we would want to know when A is 2,000. If P was $5, we would want to know when A is $10. So we want to know when is A equal to 2P. That's what you're looking for here, right? You want to know when the money's doubled. So if you just plug that in, 2P for A, 2P equals P times e to the power of RT. T is what you're looking for. We don't know that. E is a variable. R, you know the rate is 7%. If you divide this equation both sides by P, you just have that equation that you're trying to solve now. And again, you know the rate and you're solving for T, so you're going to have to use your natural logs here.